I wanted to do another example of a recursive program. If you watched the first recording where I did the factorial, I walked through how to go from a solution where you used a loop to a solution that used recursion, having a method that calls itself. Now that example, if you ran the loop solution for doing a factorial and then you ran the recursive solution, there really did not appear to be a significant time difference, and there was only one call within the factorial program. If you look at it, there's only one call recursively to the method fact. Okay, so here's the method, and within the body there's only one call to it again, and we went through how it winds out and winds up and all of that. Well, now we're going to look at Fibonacci, and if you remember, we did that with a loop. We used a loop to print out 1, 1, 2, 3, 5, and so on for the Fibonacci sequence. And so here in the handout, or in the link that I've already put in Monday's news item in a little text file to this great handout on recursion, it gives you a method that this professor uses for calculating or determining the Fibonacci sequence. Okay, and he's just showing you that you're going to give it 3 numbers and how you're going to do all of that. That's a little bit of a different approach than the one that I took when I wrote it for you guys with the loop. In my approach, we actually said, okay, I'm going to pass a number in like 5. Now give me the first 5 numbers in the sequence, which would be 1, 1, 2, 3, 5. If I wanted the first 10 numbers, I would pass in a 10, and I would get the whole sequence. In his example, he's got a couple of different ways to do the Fibonacci, and I'm trying to look for his other solution. Here, if you pass in a number, say you pass in a 5, you don't get back the whole sequence. You get back the number that would be in the 5th position of the sequence. Or if you pass it a 10, you get back just the single number that would be in the 10th position, using this nice little recursive version he has here. Notice that it makes 2 calls down here, not just one, but it makes 2 calls to itself, 2 recursive calls. Now what I want you to see here is that while you can use this to get some information back about the sequence, it is terribly inefficient and slow. So just because you can do something recursively doesn't necessarily make it the best option. So in the code here, I've basically got the fib here, what he's got there. I did another version of it where I just modified the if statement slightly, but either one of these will work and they will give you correct results no matter which way you do it, because of course there's more than one way to do something. And so here I've got the loop version where I print out the first 2 numbers, then I have a loop, and I say, okay, I want 7 more numbers in the sequence. So I get the nice long sequence right here, okay, using the loop. If I use the recursive version that he's got up there by using that fib method, if I pass it a 5, I get back the number in the 5th position, which coincidentally is 5. 1, 2, 3, 4, 5, the number is 5. And then I also did the same thing with that slightly different Fibonacci where the if statement's a little different, and I would again get back 5. Okay, so, and here I forgot to actually print it out, but I just want you to see that like factorial, I can set it up. Here I'm saying if the number is less than or equal to 2, return a 1, and otherwise take the number, subtract 1, call the Fibonacci function again, and then add it to the number minus 2 and call it again. This is very inefficient and slow. This one, the if statement is just a little different. It really doesn't matter if you return a 0, you return a 1 here. It does the same thing that this does right here and gives you the same results. Just a slightly different way to do the if statement. Now if you want to actually print out the sequence using the recursive call, it gets even a little more painful. Let me find the code. Because now I have to put the recursive call in a loop. So if I want the whole sequence to print out, the only way to do it is to still go to the overhead of having a loop, and I go from, if I want my 5 terms, I go from 1 to 5, for example, and I pass the number 1, then the number 2, then the number 3 and 4 and 5 to that recursive Fibonacci method. I get back the answer of Fibonacci of 1, which is 1. That's the first number. If I use a 2 here, I get back the second digit, which is another 1. A 3 here gives me a 2, because that is the third digit. And I have to individually print each number out. So I've made it even more inefficient or more problematic, because now I've got a long running recursive code that is now within a loop. And the reason it's so long running is the fact that it's doing 2 recursive calls, not just one. It's doing the call here and the plus call the method again. And if you look at, now he's using his more complex method for determining it up here, but if we look at when you start making 2 recursive calls simultaneously, this tracing process, the wind up and the wind down, look at how absolutely messy that is to trace through. And he even mentions in his slides, you know, just because you can do something recursively doesn't mean it's the best way to do it. It's just another optional way to do something. There are many ways to do things in programming. So just about anything you can write with a loop, you can write recursively, and vice versa. But just because you can use recursion doesn't mean it's always the best solution. Sometimes it is a little simpler to write recursive code than a loop. I will say that is true occasionally. And when you've got something like factorial, where you're just making one call to the method within itself, it can be just as quick as a loop. But when you have to start doing complicated things like this, it gets really tricky and really ugly and very inefficient. And so when I run it for like small numbers like 5, it does okay. But if I were to tell this to go up to 55, which I did earlier, it would actually, when I did this with 55, it actually was so slow it actually hung up the computer. So I'm not going to run it again. So just keep in mind, if you have something simple like factorial, you can go with a loop or a recursive solution. This actually is very simple when you look at it. This might actually be easier to interpret for some people than using a loop and having to deal with loop counters and incrementing them and setting up temporary variables and things like that. This is a little more elegant and a little simpler solution than using a loop. But for Fibonacci, while this may look a little simplistic, which I don't think it's all that simplistic, I think it's a little tricky, but while it might look a little easier than a big loop with a bunch of swapping going on for sums and values, it's really very inefficient because of this double call to the method. The recursive call is there twice. The other thing I talked about briefly in the earlier lecture, I didn't really expound on it, was tail recursion. And actually, you could say that factorial and Fibonacci both have tail recursion because the last line in here is actually the recursive call. There's somewhat of a debate among some of the experts whether or not it has to be the last line in the method, or whether or not tail recursion refers to the recursive call being the last executed line in the file. So I don't think you're going to have to worry about that on the AP exam. That's kind of splitting hairs. But if you want to, you can Google, and there's a lot of information out there about tail recursion. Some compilers optimize the method in the code a little bit more if there's tail recursion. Java does not do that. It has not been set up to do that yet. So whether you have tail recursion or not in Java, it's not going to make the code any more efficient. So hopefully that gives you a little bit of help, because I will say that if you had to do the Fibonacci on your own, that's a little tricky, that line right there. But what you're doing, since you're not doing the whole sequence, you're just figuring out, if I want the 5th element, what number is that? If I want the 10th number in the sequence, what number is that? I'm just figuring out a number in a particular location. So this thing is going to run through the sequence, but it's only going to return back the single number that's in whatever position that you've asked for by passing in that parameter. Now, again, if you want to print out the whole sequence using recursion, you have to call this method for each number, 1, 2, 3, 4, 5, 6, 7, 8, however far up you want to go. If you want the first 10 digits, you've got to call this method 10 times in a regular for loop and print out the result each time. That's the only way you can get recursion that I know of to print out the sequence. So hopefully that helps you. You can do the method either way. You can just print out a number that's in a specific location, or if you want to put it in a for loop and do that, that's fine. Either one of those that you want to do. Either way, you've got to use this basic Fibonacci recursion right here.